Welcome and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star one on your phone to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Ms. Brittany Thorpe. Thank you. You may begin.
Thank you. Good afternoon, and thank you for joining us for today's media teleconference from NASA Kennedy Space Center in Florida. I'm Brittany Thorpe with NASA's Office of Communications. We're here to discuss NASA and Boeing's Orbital Flight Test 2, the second uncrewed flight test of the CST-100 Starliner spacecraft on an Atlas V rocket from Space Launch Complex 41 to the International Space Station as part of NASA's Commercial Crew Program. Teams from NASA and Boeing just completed the Flight Readiness review for the mission, and senior representatives here to talk more about this important review are Kathryn Lueders, Associate Administrator, NASA Space Operations Mission Directorate; Stich, Manager, NASA's Commercial Crew Program; Joel Montalbano, Manager, NASA's International Space Station Program; Emily Nelson, Acting Chief Flight Director, NASA's Flight Operations Directorate; and Mark Nappi, Vice President and Program Manager, Boeing Commercial Crew Program. After brief opening comments from our speakers, we will take your questions. We'll begin with remarks from Kathy.
Hello. I feel like I've been in a press conference with Joel and Steve for like the last month now, I think, and I appreciate all of you following along. It's been a ton of work by the team here, and here we are once again getting ready for a uncrewed demonstration of the Boeing Crew Transportation System. You know, this was a flight test readiness review, but we all are looking forward to the crew transportation demonstration that will be happening next. And the meeting today kicked off with Butch and Mike once again making sure we have the right focus, because the point of this demonstration is to make sure that we're buying down risk and thoroughly testing out the system before we go put crew on the next vehicle. I really appreciated the thoroughness of the NASA, Boeing, and ULA team as they went through all the different segments and showed their readiness for us to move into this demonstration mission. You know, this is a really critical time for us as we're heading into this and getting ready to once again fly. We've learned a lot from the initial flight of the demonstration and then getting ready in the campaign up to the attempt last summer. But now the team has really worked through all that they've learned so far and is ready to go, and the team and the review today all said go for us moving forward. I really wanted to thank the team for their thoroughness, completeness, and we're ready now to go forward and get ready do our final preparations for the launch of this demonstration on May 19th and docking on the 20th. And with that, I'll hand it over to Steve Stich, the Commercial Crew Program Manager.
Thanks, Kathy. It's great to be here today as well, and it was great to have a very productive and thorough OFT-2 flight test readiness review today at the agency level. As you said, we had a go coming out of that review. We are proceeding toward a launch on May 19th. The launch time is 6:54 p.m. Eastern with a backup opportunity on May 20th at 6:32 p.m. Eastern. For that launch on May 19th at 6:54 p.m., we would dock at about 6:57 p.m. Eastern time on May 20th, and that's a special day for me. It's my birthday, so I'm really looking forward to a great birthday present here next week. You know, it's been an exciting time in Commercial Crew. It's been a very busy time, but it's also been busy getting ready for OFT-2 over the last 9 months, and it's really an honor for me to be part of the Boeing and NASA team. You know, we've gotten through the valve investigation on the oxidizer isolation valves. We talked that today at the Flight Readiness Review. We're in really good shape to go fly that system. I was out in the vertical integration facility yesterday. I could see the purge system hooked up to that service module. I could see it providing the purge that we need for flight. Also looking at the rest of the vehicle, it was just in great shape. The hatch was being closed and we were getting ready for flight. And it was cool to see the excitement in the team out at the vertical integration facility. You know, bringing Starliner online for us and commercial crew is hugely important. And as Kathy talked about the crewed flight test, the most important step right now is to go fly this orbital flight test uncrewed to test the key systems on Starliner, including the rendezvous navigation system and the NASA docking system as we dock to ISS. As I said, the hardware is really ready. It's great to see the team in place to go fly the flight. It was great to see everybody at the Flight Readiness review today as well. We have a few items of, I would say, standard open work to close out on the way to flight. No really big issues coming out of Flight Readiness review today. We're excited to fly. Starliner is a great vehicle. We will learn a lot, I think, on this test flight. Really the only way to get the final piece of data you need to fly crew is to go fly the vehicle in the environment, and that includes flying it during the ascent, on orbit, and then and docking in proximity to ISS, and we're about to go do that. We will have our launch readiness review on May 17th. That's the next milestone heading into flight. We'll also have a Starliner mission management team meeting that day, and then we'll get into the weather briefs. Kathy talks about being in press conferences. I feel like I've been in a weather brief for about the last month and a half, but it's great to get back. That means we're operational, we're getting ready to go fly, and when the weather's right and the systems are right, we'll go fly the flight. And now I'll turn it over to Joel.
Thank you, Steve, and thank you for joining us today. You know, we had a great review today summarizing the work over the past year, and the International Space Station team is ready for the launch and the arrival for Starliner to the space station. It's a busy time on board ISS. As you heard me say multiple times, the Crew 4 continues to excel on orbit, and it was awesome to see the Crew 3 splash down last week after 6 months on board the International Space Station. This mission, OFT-2, is a major stepping stone for Boeing and NASA to enable additional crew launches to the space station, and the International Space Station is eagerly awaiting this landmark flight. The ISS crew on board will be monitoring the approach and will have the ability to send commands to the spacecraft if required. That's not nominal, but they do have that capability if needed. As we've talked, the OFT-2 is carrying about 500 pounds of cargo to station and returning about the same amount. In fact, today, the on-orbit crew talked to the ground team in preparation of the cargo coming up and down and making sure everybody was in sync. As Steve said, we're looking at a May 19th launch date. Soon after that, we'll be looking at the SpaceX 25 cargo mission currently targeted for June 7th. And with that, let me hand it over to Emily. Thank you.
Thanks, Joel. I'm Emily Nelson, NASA's Acting Chief Flight Director. The NASA and Boeing teams have been working really hard to prepare for this exciting test flight, and I think that hard work was really evident in today's review. Mission Control in Houston and the NASA and Boeing operations teams are ready to execute this OFT mission as we look towards that key step towards the crewed test flight. We'll start our final mission rehearsal tomorrow. The ISS crew will complete their training this week as well, and we'll close out our final preparations for launch. We look forward to getting some experience with this new spacecraft in orbit during this test flight, and we're looking forward to having a second unique commercial spacecraft bringing our astronauts to the International Space Station. With that, I'll hand it over to Mark.
All right, thank you, Emily. Most of my career has been around launching and processing human space vehicles and specifically the space shuttle. There's something about this environment that we're in today with launching or preparing to launch and doing it in the mission environment that really brings the team together. It makes the strongest teams even stronger. So that's a lot of what I saw today and really made me feel good to be back in this kind of environment again. The Boeing team is prepared and ready. The NASA-Boeing partnership is really strong, and it's a reflection of all the hard work that's been done. OFT-2 is the second orbital test flight. The first one, we had some demonstrations that were completed with landing and launch, and now OFT-2 is going to focus on the things that are in between, the Starliner's ability to rendezvous and dock, receive commands from the ISS, and demonstrate our ability to hold and retreat. So we're looking forward to that. There's 15 demonstrations that are planned with respect to approach and docking and some docked activities. We're pleased really with the results from today to proceed to launch. Again, it's a reflection of how hard the teams have worked together on the NASA side, on the Boeing side, and with all of our suppliers. As far as the spacecraft status goes, the crew did some comm end-to-end tests yesterday. I was up at the launch pad and ran into them, and they spent some time in the crew module. They said they didn't want to get out. And they're just so complimentary of the way the vehicle looks, so they're very excited about this as well. Today we closed the crew module hatch to roll past the leak checks, and we're on track for the 18th roll to the pad and the 19th launch. One additional note: we have cycled the aux valves 4 times so far. Got a couple more cycles planned, and they're working really well. So with that, I'll turn it back over to Brittany.
Thank you all. We will now begin the question and answer portion. Please remember to stick to one question and identify whom it is directed. If we have time, we'll allow reporters to ask a second question. You can enter *1 on your phone to be entered into the queue at any time, and you can enter *2 if you'd like to be removed from the queue. Shortly after we conclude, you can listen to a replay of this teleconference online. We'll begin with our first question from Bill Harwood, CBS News.
Hey, thank you very much. Well, I'm going to ignore valves and all of that for now and look ahead to rendezvous, and would like to ask Emily, could you talk a little bit about how the Starliner rendezvous is different from what we're used to with SpaceX? Mark mentioned all the demonstrations that are planned during rendezvous. Can you maybe highlight a couple of those and give us a sense of what you guys are looking for in this rendezvous? Thank you.
Absolutely. So it's well, the first thing I would note is that this being a test flight, we've got to demonstrate all of the new technologies that Boeing has put into their spacecraft and confirm that they all work as expected. And so most of those demonstrations are tied to first establishing one sensor that can be trusted and then comparing the next sensor to that first sensor and so on through the rendezvous period. So one of the most important and really kind of the coolest sensor that they've got on their spacecraft is called Vesta. And it basically looks for the silhouette of the space station, and once we can confirm that it's seeing the space station correctly, it's identifying where it ought to go, and the space station's fairly large. We'd like for it to arrive at the correct port. Once we can identify it's going to the right place, we'll do a couple of demonstrations once we get close in where the spacecraft will stop to demonstrate that if we tell it to stop, it will in fact stop. It'll automatically retreat some to demonstrate that we have that retreat capability. And then we'll press into the final rendezvous and docking. And so it's mostly just about demonstrating all of this new technology to make sure that we have a good sense of performance, that we characterize how all of that's going to work before we finally complete this mission.
Thank you. Our next question is Chris Davenport from the Washington Post.
Hi, everyone. Thanks for doing this. Good evening. I guess for Steve, you had said there were just a couple of items, nothing serious, that needed to be closed out. Just wondering what those are.
Yeah, there's just a few items. I would characterize them as final landing site readiness for a couple of the landing sites that need to be closed out. And then we track, like on the NASA side, for example, we do various inspections at various points in the flow to look at the hardware. Some of those items need to be closed out. Those are standard open work. There was really nothing that was a big item that we're tracking as we move forward toward launch. So it was a very clean review compared to many that I've participated in.
Thank you, Steve. Our next question is Irene Klotz from Aviation Week.
Thanks. Good evening. For Kathy, I've heard that the crew flight test might actually be conducted with just the 2 astronauts, Latrell Moore and Mike Fink. Is that correct? And what would be the trade-offs in having 2 or adding a 3rd person to that crew?
Hey, Irene, I'll let Steve take that one because he's been working that one.
Yeah. Thanks for the question, Irene. Yeah, we are in the process of really looking hard at the crewed flight test mission. after we get through the orbital flight test and look at the data for that. We're finalizing the mission duration for that flight, and then we're in discussions relative to the final crew complement and what we're going to do. So we're hoping to make that available, in the summer time frame. I think I've talked about that before. But we're just looking at all the different options relative to the flight, and then what's the right thing to go do as we move forward. So for that flight test, again, remember, it's another flight test mission for commercial crew.
The only thing I'd add, Irene, is that we've got to roll this particular complement in with the rest of the staffing of the crew increments, right? So what's important is when's the timing, what are the other crew increments going on, and then balancing the crew complement against that. So that's kind of part of what we're trying to do. We've got to go understand when is the crewed flight test schedule and those pieces, and then kind of the staffing for all the station increment crews, and then what's the right number of crew members to have to be able to staff all those requirements. And so that's why we don't have the answer right now, because we're kind of waiting to see when all the different pieces come together so that we can, respond to that question correctly.
Our next question is Michael Sheets, CNBC.
Hi, all. There was some really excellent reporting on the oxidizer valves, as well as plans to redesign the full valve system, either on a short-term or long-term basis. I'm curious, based on previous discussions, and this question is probably for Mark as well as Steve, when Boeing started to look at redesigning Starliner's valves itself, as well as whether or not those redesigns will be complete before the CFT test. Thanks.
Okay, I can take that. So as you all know, we've walked through this before. There's been a very thorough set of troubleshooting and testing that was performed by us, NASA, and our suppliers, and a detailed fault tree was developed. So the first step to understanding what you're going to do next is understanding what the root cause is. And so that has been agreed to for the team that did the troubleshooting and the testing based on all those results. And now we have a mitigation for OFT-2, and we've explained all the mitigation steps that are involved in OFT-2. So the second step is, where do we go from here? There's still a little bit more testing that has to be complete. We have to close out a couple other areas of the fault tree, but we're already looking at different options of what we do for CFT and what we do for missions after that. So they've not been decided exactly what we're going to do yet, but I can tell you that a valve redesign is definitely on the table, and once we get all the information that we need, we'll make that decision.
And I really don't have anything to add what Mark said. Now that we understand root cause, we understand the factors, we'll go look at and participate with Mark and the team and see what areas, as Mark talked about, could we go enhance the valve with different materials, a different way to seal it, those sorts of things. So NASA's heavily engaged in participating.
Okay. Our next question is Jeff Faust, Space News.
Good afternoon. Question probably for Joel. I think you've talked about having Starliner at the station for 5 to 10 days. I wanted to confirm if that's the case, and what sort of factors like landing site weather would drive the decision for the length of the stay at the station and the undocking and return. Thanks.
I'll start, and then I'll hand over to Steve, and he can give you all the details on the landing. It's a minimum. We're looking at somewhere. Total mission duration, probably 5 to 8 days, and we'll be looking at landing. There's some minimum requirements that the teams are going to want to get done with the vehicle after it's docked to the ISS. We have some cargo, like I said, that was delivered, and then we have some cargo we want to install in the vehicle. Plus, we'll do some testing with the vehicle on orbit, just to, some communication paths, and just basically checking out the vehicle. And then the commercial crew guys will be looking at weather at the landing site, working with the Boeing team, and picking a good landing date. And let me hand it over to Steve.
Yeah, obviously this is a test flight for NASA and for Boeing, and so once we get, a couple of factors relative to landing would be getting through the docked activities, all the things that are on our flight test objectives list, and then setting up for good weather. You know, the prime site is White Sands Space Harbor, which is the old Space Shuttle landing site. It's where we landed the first orbit flight test. And then looking at the weather there and the different times, there's kind of two sets of opportunities. One's kind of an ascending trajectory into White Sands with kind of an evening landing when winds in the desert can be problematic at that time. And then there's a set of descending passes maybe 2 days later that would be a night landing. And so when we get a little closer, we'll weigh the weather. Obviously, with a new spacecraft, we want to be very cautious about the weather conditions, and so we'll look at that and evaluate it and then make the right call on the weather.
Okay. Our next question is Elizabeth Howell, space.com.
Hello, everybody. Thanks for taking the time tonight. I was wondering if somebody like Kathryn or Steve could characterize just how much of a process this was, this getting OFT-2 ready for flight compared with maybe another program at NASA. I'm just trying to characterize this in terms of the difficulty, the obstacles surmounted to get to this incredible point. So do you have any sort of insight about whether this was as difficult or more difficult than other programs of this type?
Well, I'll start, and then I think that, you know, and Steve, you can add, and honestly, Joel, you know, human spaceflight, and we say this over and over, it sounds kind of cliche, but human spaceflight is hard, right? And I know people sometimes get tired of us saying that, but, you know, when you have to go through the process like we've had with this program, where you design and test and find things and have to fix it and then get back up again, that's kind of the process that we have to get through. And so I think this program has gone through that same design, build, and test that other programs are going through and working through. I think what I'm really proud of as a team is that we're doing it as a team between NASA and Boeing. And so, and I think that's also exemplified in the other NASA projects that we have out here. But no project, I haven't seen it yet. You know, I've been working for NASA for 30 years, and every development so far that I've been involved with, and I've been involved with, you know, 5 spacecraft right now, every development has been hard. And so you just have to recognize it and do the work and spend the time and make sure that you're buying down the risks and continue to solve your problems and move forward. And I don't think that this one has been any different for it. And Steve, jump in. You got any?
Yeah, let's see, Kathy. I've been through a number of them in different programs as well. I think back to Space Shuttle and problems that we had to stand down for a period of time to go fix them. One that comes to mind is when we had a flow control valve anomaly in the hydrogen system. We had to go off and do a whole bunch of testing and then put in some new flow control valves to convince ourselves that we were safe to go fly. And in this case, you know, we spent the better part of 8 or 9 months here first trying to understand what was the cause of the valves to stick, which we completely understand now. Mark and his team put in a system to mitigate that. We've sealed the valves. We put in a purge system. And, you know, it's just what we find in spaceflight is, you know, challenging all the time, and you find things out about the vehicle that you maybe didn't know. You go address those technically. You go run the right test. You put the right people and the right teams in place. Go solve the problem. And then when you're ready, which we are, we go fly. So thanks.
Okay. Just a reminder, to be added into the question queue, you can press star 1. And our next question is from Stephen Clark, Spaceflight Now.
Thanks for taking my question. I'm just curious, with the 2-year or so wait for another shot at the orbital flight test, during that time, was there any work done to make this spacecraft closer to the crew configuration than it was for OFT-1? And also, the launch abort system, is that going to be armed and ready for OFT-2? And if it's not going to be armed, why not? Thank you.
Yeah, this is Steve Stich, Commercial Crew Program Manager. I'll have to think back of the things that we've changed or over the last 2 years and make it closer to a crewed flight vehicle. First of all, for aborts, the launch, the abort system is going to be enabled. So the Atlas vehicle has a system that can detect problems. We flew that in a monitor mode on OFT-1. That worked fine. So for this particular flight, all the aborts for Ascent are enabled. The service module has the 4 launch abort engines on board for this flight, so it's very much the same as a crewed flight. This service module is exactly the same one we'll go fly. Same kind of design will go fly on the crewed flight test. It's a lightweight service module which has been planned for many years, so it's the exact configuration we'll go fly. And then if I think about things that were upgraded that are closer to a crewed flight, we added a cover for the docking system on this flight that will fly on the crewed vehicle. We've improved the hatch seals. That'll be the same as for the crewed flight test. Those are probably the primary things I can think of. There's probably a few more, but this vehicle is very close to what we'll fly for the crew coming up. So, and it's good to get it tested in that regard.
Our next question is from Ken Kramer, Space Up Close.
Hi, thank you for taking my question. And let's say good luck to Steve Stich on your birthday. Hopefully you launch and dock the next day. So my question is for Joel and maybe Steve. I'm wondering about the Norris system, the nitrogen-oxygen recharge system. Can you talk a little bit about, in detail, about how you detach that and get it into the Starliner? Can you talk about the weight and the size of it? And how many of these do you have? And when would you expect to send it back? Thanks.
Okay, so we have a number on orbit, I would say over 10 on orbit. And as you know, we use these on a regular basis. We're planning to bring 3 home on board the Starliner. And so we've been bringing these home over time. Generally, we've been bringing them home on the cargo missions. We did have an opportunity to bring 1 home on the Axiom mission, so we did that. But this will be the first time we're bringing 3 tanks home. And as you can imagine, these tanks, they're brought home, they're refurbished, and they're flown again. So it's important that we pack them carefully. And so there'll be a foam insert that will install these in, and then they'll be packed within the vehicle such that they can accept the landing loads and be available for us to refurb them and fly again. And so again, these are empty tanks that have been used. Right now, they're either in the Columbus module or the Japanese module just for storage, but we'll go ahead and move them to the Starliner and bring them home.
From our perspective, Joel asked to bring these home, so we did a special analysis, have some special fixtures to go ahead and restrain them during the deorbit entry and landing. They're special tanks, as Joel said. They're made of composite, so we've taken extra precaution to look at all the loads and make sure that they're good because we know Joel wants to reuse the tanks. So from a commercial crew perspective, that's what we've done.
Thank you. Our next question is Jackie Waddle, CNN.
Hi, thanks. So question for Steve or Mark, just to follow up on Michael's question. Can you tell us a little bit more about when exactly the decision was made on the short-term versus long-term adjustments to the valve design? And can you give us more detail into exactly what those are, what the changes are?
So the beginning, so we started the troubleshooting, got through the fault tree, and determined that we had some nitrates in the system which were causing, you could call it corrosion, and that ended up binding up the valve. So that's the, and we took valves out so that we could tear them apart to see if that was existing inside the valves. It was. We did testing, validated that with moisture and the nitrogen tetroxide and the aluminum valve body, that between those 3, these nitrates can form. So we had to look at what can we do in the near term to get the service module back into service, and then there may be a longer term solution that we want to go and investigate. So the immediate fixes were to provide a purge system to the area so that moisture doesn't get into the valve. It doesn't get into that area, and that purge system is nitrogen purge with like a baggie around it. So that's the immediate mitigation. That's one of the immediate mitigations. We'd also in the testing found that there was an area where moisture could get inside the valve, and so that area was sealed off so that no moisture could get into the valve. And so far, all of our cycles have demonstrated that these nitrates are not building up, and we're getting good valve actuation. A number of other smaller, let's say, additional mitigations were put in place that won't go through at this point, but we're very confident for OFT-2 that we have a system that is going to operate properly. And the Monday, when we did the last cycle, it's working just fine. So now we have to think about what are we going to do in the future, because this baggy system and the purge may not be what we want to do in the long term. So we want to do a little bit more testing to understand not only that these nitrates form inside the system, but how fast do they form, and what's the catalyst that makes them form a little bit faster. So there's a little bit of additional testing that we want to go do, and based on those results, we'll solidify what kind of changes we'll make in the future, which again, we've got a team already working some of those possible changes. And the way the design process works is that you put several options on the table, and then you down select based on the information that you gain from testing and analysis. And then we'll, of course, run some kind of qualification test on it to make sure that they work properly. But again, a valve redesign is definitely on the table, and we'll probably know more in the coming months which option we select. Steve?
I think you said it really well, and I think we basically, in terms of decision short-term, long-term, chose to put the mitigations in place that Mark talked about, stay with the qualified valve design. We can go fly the flight with this. We know this flight's safe to go fly. We know the valves are working, as Mark talked about, cycle them 4 times, two more times coming up, and then long-term we'll have to take the data we've found in the investigation and look inside the valve. Is there material changes we would like to make in the valve, or do we want to seal the valve differently, or those sorts of things?
Our next question is from Lauren Grush, The Verge.
Hi, thank you for taking my question. Sorry to belabor the point. I just want to follow up on what Jackie was saying. I guess we're a little confused because last week we were told that the valve design was going to stay the same, and now we're being told that the design change is on the table. So I'm just curious if something new happened between the last press conference and now, or has there always been a possibility of having a design change of the valves on the table? Thank you so much.
I'm sorry for any miscommunication that occurred last week. The short-term solution has been not to have a redesigned valve. That's always been the case. And the long-term solution, we've been looking at options for at least a month, if not more, and it has included a valve redesign as an option.
It may have been a little bit confusing just because, obviously, for OFT-2, the team understanding the timing and looking at and carefully working through the mitigation. There's a plan for OFT-2. The team's going to work together a plan for CFT and a plan for PCM1. We're putting together a plan for each of our vehicles that will close on the risk for our crew. Right? This is, and the team had a great plan today for the uncrewed demonstration vehicle.
Our final question will be from Jim Siegel, NASA Tech.
Hi, everybody, and thanks for taking my call. I wonder if you could, I think this might be for Steve, but could you talk a little bit about comparing and contrasting the Starliner with the Crew Dragon, and terms of cargo and crew capabilities, and I'm curious about whether or how you will decide when both of those are operational, how you're going to decide what particular mission is going to go on each one of those. Is it just the next one up or what? Thank you.
Yeah, I can take that question. So, the vehicles are very comparable in terms of our requirements were to fly 4 crew to the station and return 4 crew. Both vehicles accommodate 4 crew. Both vehicles provide for suits for the crew for the launch and landing in the key dynamic phases. Both vehicles are able to carry cargo, and in particular, both vehicles are designed to carry powered cargo for the space station program. For the human research program, it's very important to carry up samples in freezers, polar and glacier, and then also return those. And so both vehicles accommodate the powered payloads. The designs meet the NASA requirements for aborts. We had some very stringent requirements for aborts. We wanted the vehicle to be able to abort all the way from the launch pad all the way through orbit. Both the Starliner and the Dragon meet those requirements. Both vehicles had to have various safety requirements. We need to have the vehicle be able to accommodate a crew in safe haven while docked to the ISS, and we've used that a few times with the Dragon on board to have the crew go in for a short period of time when there's some micrometeor orbital debris or something like that on station. So both systems are very comparable. The designs are a little different in terms of Boeing has a service module that has the propulsion. Dragon tends to have the propulsion all contained in the Dragon. Dragon has a trunk, so there's a little differences there. We didn't prescribe those kind of requirements. For the long term, where we want to end up is 1 flight a year, 1 post-certification mission a year for Boeing, and 1 flight per year for the crew Dragon. And, we've been using the Dragons for crew rotation here in the near term. The plan is to have the orbit flight test and collect the data from that and review it. Then we'll go move into the crewed flight test for Boeing. Once we do those 2 flight tests, we'll move into the final certification of the vehicle. And then at that point, whatever that schedule lines up, we'll assign Starliner to the soonest post-certification mission that we can at that time.
We have one more question in the queue. Michael Sheets, CNBC.
Hi, I appreciate you taking a second one here. I think this one should be probably for Mark as well, but on the more technical aspect of this valve situation, once the propellant system has moisture in it, how many days have you seen in testing before the corrosion is a problem with the current sealant fix that you've applied for OFT-2?
I think your question is, let me play your question back and make sure I got it right. You're looking to see how many days before nitrates form with the current valve configuration that we have where we put a sealant on it?
Right, both that and I would also welcome information based on what you saw without the sealant applied.
I believe, I'll have to go back and look for sure, but I believe that once we put the sealant on, we did not have nitrates form inside the valve. And I'll go back and make sure that that's correct. Before the sealant was put on, what we saw with the valve testing that was done was, I believe that the nitrates formed within 5 to 7 days.
And this is Steve Stich. I'll add, when we did the testing at White Sands with the valve that was sealed and the bag with the purge around it, we tested that for the whole profile from propellant load through the flight. And when we took those valves and sent them to Marshall, there was no corrosion products inside the valve that would cause any kind of stiction. So the purge plus the sealant eliminated those nitrate forms. And then Mark's right, it was about, I think we ended up with permeation across the Teflon seals in about 5 days, and it was a few days later that we were able to see the corrosion products start to form based on, we were measuring current, we were selecting the valve, looking at current, and you could kind of see the current move up, and that was again based on testing at White Sands with 3 valves that did not have the purge, did not have the sealant.
Thank you all. With that, I will hand it back to Kathy for closing comments.
So thank you again for, supporting the news conference, or the press conference. I appreciate everybody's continued interest in us progressing towards our flight readiness. It's great to be here again, getting ready for another launch. It was great to sit there today and listen to the hardware being ready, all the analysis, testing being done, closed out, the flight teams once again getting ready for final preparations. We're already scheduling our meetings with our favorite meteorologist, and so we're getting ready for more quality time with Tim and getting prepared for final launch readiness reviews next Tuesday. And hopefully, if everything goes well, maybe Steve Stich will get a great birthday present with the docking, finding that out. So just one more reason. It's been a great spring so far, and we're really looking forward to us seeing this final demonstration occur. This is a test flight. We're going to learn a lot from this test flight, and it's going to be really exciting to see. Thank you again for being here.
Thank you. That does conclude today's conference. Thank you for participating. You may disconnect at this time.